So, yesterday we have discussed about efficiency of a steam engine.
But here the objective is not to generate power. What is the objective? The objective is to cool down, to extract more Q dot.
Okay. So, yesterday we have discussed about steam engine and the efficiency of a steam engine. So, heat engine can either be steam engine, it can be a petrol engine, it can be a diesel engine. So, steam engine is a external combustion engine, petrol and diesel engine are internal combustion engine. So we have derived the efficiency of a steam engine, which is otherwise a heat engine. Okay. So now, today we will discuss the first law of thermodynamics. So refrigerator and heat pumps are also uh, like something similar, but the purpose is different. Okay. So in a heat engine, you do work on the surrounding, but in refrigerator or heat pump, you take work from the surrounding and by taking work from the surrounding, you transfer heat from low temperature refrigerator chamber to the high temperature surrounding. Okay. Uh, yeah, so, like, so let us say this is your refrigerator, this is your refrigerator chamber. So and let us say this is your room. Okay. So let us say this is your room. Okay. So this is your fridge and this is your room. Okay. So you are keeping this uh, fridge chamber cooler. Okay. So why do we keep the fridge chamber cooler? Because so that there will not be like the uh, storage items will not get spoiled. If the temperature rises, there will be bacterial reaction and it will get spoiled. At low temperature, it does not get spoiled. So you can observe that in summer, the food gets spoiled quite fast as compared to winter. Okay, so keeping in low temperature, the food does not get spoiled. So, so the question is, a refrigerator is to maintain eatable kept inside at 9 degrees centigrade. So you want to keep the, like say, your eatables are here. Okay, so you want to keep it at 9 degree centigrade. Okay, and you will and the room temperature is, let us say, 36 degree centigrade. Okay. So um, earlier we have like drawn and how does the the refrigerator works. Okay, so let us say this is your source, this is your sink, this is your working substance, the refrigerant, and you are taking heat Q2 and throwing away heat Q1 to the room. Okay. So you are taking heat Q2 from the sink, okay, and throwing away heat Q1 to the room by doing work on the compressor. So in case of a heat engine, the RO's direction will be different. Okay. So this sink is nothing but your fridge chamber. Fridge chamber. Okay. Chamber. Okay. This is fridge chamber, and where it is throwing the heat, it is throwing the heat to the room. Right. Right. So you know your COP is nothing but your what is your performance measure here? It is nothing but your how much heat you are extracting, right? So how much heat I am extracting, that is my performance measure. That is otherwise called the Q2. Okay, and how much energy you are spending in extracting heat Q2, that is W, right? So COP is equal to Q2 by W. So Q2 is important here in case of fridge. In case of heat pump, Q1 is important because heat pump, this is the area of concentration, whereas in fridge, this is the area of concentration. Okay. So Q2 by W is your COP. Okay. So it is not in your scope in till 12th, but there are something called a pH diagram and the TS diagram of refrigerator or air conditioning. So the pH diagram, the pH diagram are called, otherwise called pressure and enthalpy, pressure versus enthalpy diagram. Okay, so this diagram looks like this. Okay, so here, like it is the refrigerant, uh, it can also, this refrigerant can be like it can be uh, below the, means before it can go beyond the saturated line actually. So this is this. Okay, so this is the process. So what is happening, like it goes like this is the, it is a cycle, and it like this line. So it is like this. Okay, it is like this. This is like this. Okay. So this line is called the saturation line. Okay. So this is a refrigerant, and this line is called the saturation line. Saturation line. So to the left side of it, you will have liquid. Okay. Inside it, you will have liquid plus vapor. To the right side of it, you will have vapor. Only vapor. So what is happening here? Like this part is your evaporator. Evaporator. This part is your condenser. Condenser. This part is your compressor, and this part is your throttle valve. Throttle valve. Throttle valve. Okay. So these are the four different components, and it looks in the pH diagram like this. Okay. So there is a corresponding pH diagram also for that. Okay. Corresponding pH diagram. So this is your temperature. This is this, and okay. So in pH diagram, that here anyway the temperature remains constant. Then it will go like this. It will come down like this. Then it will go like this, and here corresponding to this, we draw it like this. It will become a TS diagram. Okay, here T and here S. That is the on like S is nothing but entropy. Okay, and then this is evaporator, this is compressor, and this point is 1, this point is 2, and let us say this point is 3, this point is 4. Okay, so these are the 4 points in pH and pH diagram. Okay, so yeah, so this numerical is very simple one. Okay, I am just telling you what are the different components. Okay, so just for your understanding, see, solving a problem is not a big thing, but understanding what is there inside a refrigerator, that is important. You can solve any number of problems if you understand a concept. Okay, so in the 12th stage, you may not need this pH diagram, but you just understand, okay, evaporator means evaporation. That means no temperature increase. Condensation. So here in condenser, the supersaturated vapor is coming to the liquid stage. So this here it is becoming liquid plus vapor. Yes. Okay. Here from here to here it will start condensing, but here it is liquid plus vapor. Like see, here it is vapor. Okay. So from vapor it has started getting cooled down and it has come to liquid plus vapor. So liquid has started liquid formation has started. So here it will become liquid plus vapor. This inside this two saturated line, this is called the liquid line, and this is called the vapor line. Okay, beyond this it is only vapor. Behind this it is only liquid. In between these two lines it will liquid plus vapor. So this supersaturated vapor will start becoming liquid from here, then liquid, and beyond this it is only liquid. So in between this, only condensation is taking place, only condensation. So during condensation, the temperature remains constant. Similarly, during evaporation, the temperature remains constant. Okay. And okay, so we know that COP is equal to Q2 by W. Okay. So you know as per first law of thermodynamics, Q is equal to del U plus W, right? Del U is equal to 0 because it is a cyclic process. Cyclic process. Okay, del Q. Okay, whatever. Okay. So this COP again become Q2 by this W is nothing but Q1 del Q, which is nothing but Q1 minus Q2. Okay. So this becomes Q2 by Q1 minus Q2. Okay. So in heat engine, it was like W by like what is the work done divided by Q1, right? So it was becoming Q1, W is nothing but Q1 minus Q2 by Q1. Okay. So this is becoming 1 minus Q2 by Q1. Okay. So if for a ideal and reversible process, this Q2 you can replace by T2. 1 minus T2 by T1. That is the efficiency of a Carnot engine. So a ideal reversible engine, this T2 can be replaced by T2 and T1 in Carnot engine. Similarly, if this refrigerator is going through an ideal and reversible process, the ideal efficiency will be just Q2 you replace by Q2, Q1 by T1, Q2 by T2. Okay. So here you know your T2, T2 and T1. So you know your T2 is your sink temperature, right? So this is your sink temperature, which is 9. 9 plus 273. You have to write in Kelvin. Okay. And your T1 is 36 plus 272. So you know T2 39 that is equal to 282, right? Yes. And this one is 390. Yeah, 309, right? So this becomes 282 divided by 309 minus 282. So this becomes 282 divided by 27, right? So how much you are coming? 10.4. So COP is equal to 10.4. Okay. So this is how you derive the coefficient of performance of a refrigerator. If it is a heat pump, instead of writing it as T2 by T1 minus T2, you will write T1 by T1 minus T2.
1 minus T2 by T1. That
one. T1 by T1 minus T2. That's all. If it is a heat pump, instead of T2 in the numerator, it will become T1 in the numerator. Okay. And the difference between a air conditioning and a refrigerator is this whole room you are cooling. Okay. So when you are cooling the whole room, the whether a window air conditioner or in case of a centralized air conditioner, you are cooling the whole building. Okay. So this it will be surrounded by this whole room will get cooled. This whole room will get cooled. So this room will become the sink, and the outside the room everything will become the source. So instead of this fridge chamber, your room will become the sink from where you are throwing heat to the outside the room. And if you are air conditioning the whole building, then your whole building will become the sink, and anything outside this thing will become the surrounding. Okay. So that's the, otherwise the components in a fridge or air conditioner are all same actually. Okay. So one room air conditioner. So the capacity of a air conditioner or fridge, the capacity of a fridge not only told in terms of volume of the refrigerator like 165 liter or whatever. Another capacity of refrigerator is called in terms of tonnage. Okay. So tonnage means cool. Actually, whatever is happening, na, this is happening in the evaporator. How much you are cooling that? So how much heat is being absorbed? Like normally this Q2 amount of heat is getting absorbed in the evaporator. Okay. So the more heat you are absorbing in the evaporator, more is the capacity of your fridge. Okay. So normally this refrigerator capacity is told in terms of tonnage. Okay. Tonnage. So 1 ton refrigerator means what? It can cool. It can the amount of heat taken to convert 1 ton of ice to 1 ton of water. Okay, that is latent heat of melting or whatever. So the amount of heat taken to convert 1 ton of ice, 1 ton means 1000 kg. Okay, the amount of heat taken to convert 1000 kg of ice to 1000 kg of convert 1000 kg of ice to 1000 kg of water is called 1 ton refrigeration. Okay. So the more is the tonnage, better is the capacity of the refrigerator. So you know what is the tonnage? Like 1 kg of ice, 1 kg of ice when you are converting into 1 kg of water. Normally, I think I don't remember exactly. You need some 80 kilocalorie of heat. Okay, that you can convert into joule. You just see how is the conversion from calorie to joule. So that much of heat you are observing to convert 1 kg of ice to 1 kg of water. So if it is 2 ton, it is like if it is 1000, 1 ton means you have to multiply this 80 kilocalorie by 1000. Yeah. So that much of heat you are observing. Then convert into joule. Yes. So calorie you can convert into joule. Into okay. 1.4, so, I don't know in JE level, in advanced JE level or JE level, they may be asking, okay, what is the capacity of a refrigerator? Whether it is in terms of volume that is being getting cooled or in terms of tonnage. Tonnage also is like the when you get the refrigerator manual or the AC manual, they will specify it in terms of tonnage. More is the tonnage, more is the cost of the refrigerator. More is the cooled volume, more is the, you are telling I have a double door fridge, triple door fridge. So you are maintaining different temperature in different chamber and the volume of that fridge is getting increased. So 165 liter fridge and 210-liter fridge. The 210-liter fridge will be more costly because you can put more substance, more eatables in that. Okay. So, so the bigger the fridge, more is the cost. Bigger the fridge, more is the tonnage also. That's why more is more the cost. Amount is because your compressor will be of higher capacity. Higher capacity. Amount of space has to be cool. Yeah, and you have to use a bigger compressor. Bigger compressor will more costly. Everything like you will have more piping in the evaporator and all that. So because the hardware is more costly, that's why the cost of the refrigerator goes up with tonnage and volume. Okay, that's that's the numerical on refrigerator and how you get the COP. So it can be there can be a question on that. There can be a number of questions on this heat pump refrigerator. Just understand the concept, you can solve a number of questions. Okay. Okay. Thank you.